Hello, welcome back. I am Rajendra Bade, and in this video we'll study sectional orthographic views. In this video, we'll try to understand basic rules of sectional views. Now watch this diagram. It is a machine part. Clearly you can identify two parts here, two portions here. A plate at base which has thickness 20 millimeters. It has two holes. Each hole is of diameter 20 millimeters. And this plate has a vertical cylinder attached to it. This cylinder has a hole of diameter 52 millimeters. That is radius 26 millimeters. This arrow here suggests you front side. So on back side there is a vertical slot. So in bird's eye view we have divided this object in portions. Now watch something new in this diagram. There is a line like center line shown in the diagram, but it has its end dashes dark. And not only that, at its ends there are arrows which are parallel to this front arrow. Such a line which is like a center line but end dashes are dark suggests you a section line, a cutting line. And arrows associated with the cutting line suggests you the direction in which the section is visible. Now actually how this object is cut, try to understand. But before I cut this object, once again focus on this line which has its ends, center line which has ends dark dashes. Okay. Now here I have cut this object in two parts by a cutting plane. This is the cutting plane. This cutting plane is a parallel to VP. It makes two parts of the object, front side portion and back side portion, front portion and back portion. Here that cut you can clearly see. When a plane cuts object, it creates edges, new edges on the surface of object. So this is how by a vertical plane which is parallel to VP, we have cut the object. Now since it is a vertical plane, in the top view it appears a line. But not only that, this plane is parallel to VP and therefore it is perpendicular to side plane also. And therefore in the side view also cutting plane appears a line. Now sectional views are special purpose views. Because we want to show internal details of the object in our drawing, we have taken this cut. Now imagine observer is watching in this direction from front and he wants to see internal details. The portion nearer to the observer must be removed. So these are the two parts and this is portion nearer to observer and it is to be removed to watch the section. Now when solid part gets cut by a cutting plane, new surface gets created, that is section. In actual drawing, it is to be shown with hatching lines. You will understand. So this is newly generated surface, that is section. But watch here, inside the hole, this semi-cylindrical surface. This semi-cylindrical surface is original surface. It is not the surface that is created by the cutting. But this colored surface in the drawing now on your screen, this surface is a fresh surface that got created because of the cutting. Now try to understand. The portion nearer to observer is to be imagined removed. One thing. portion nearer to observer to be imagined removed. When you cut an object, a fresh surface gets created. That surface is a section. Some hidden details get exposed because of cutting. For example, this hole gets cut and therefore inner surface of the hole is revealed now in sectional view. Similarly, these two holes on the base plate, inner semi-cylindrical surfaces are revealed now. So some hidden details get exposed because of cutting. But some hidden details, for example this slot, some hidden details remain hidden even after cutting. So even if we have cut this object from front, the slot on the back side is still hidden. So what we studied here, because of cutting, fresh surfaces get created. Those surfaces are to be shown by hatching lines. Some hidden details get exposed because of cutting. That is, those hidden details become visible. Some hidden details remain hidden even after cutting. For example, this slot. Now we'll actually solve a problem and you will understand how we are going to use these observations to draw sectional views. Read this problem. Pictorial view of a machine part is shown in the figure. Take a section along AB. Now watch here. So this line is the cutting line and you are asked to cut it in this manner along this line. And draw sectional front view, top view and left side view. Sectional front view. Okay. Now since we are studying right now, initially we'll not draw sectional view. We'll draw 3 views of complete object. Then we'll convert front view into sectional front view, so that you will understand the difference between the complete front view and sectional front view clearly. This is to clear your concepts. If you are asked to draw sectional front view, it is actually not necessary to draw complete view first and then convert it to sectional view. In following problems, we are going to draw sectional views directly. But in this problem, we'll draw front view complete first and then we'll convert it into sectional view to clear our concepts. Let's proceed. This is front side. We are asked to draw front view, top view and left side view. Left side view to be drawn on the right side. So as usual, we'll identify orientation of length, width and height axis. We'll identify overall dimensions. And we'll draw 3 blocks for front view, top view and side view. This is orientation of length, width, height axis. Parallel to this arrow, that is width axis. So of course third axis is length axis. Now let's check all dimensions. Parallel to length, this is length axis. 100 plus 100, 200. But check here, this distance 200 is in between centers of these 2 holes. And boundary edges are curved edges. So radius of boundary curved edge is 20. So 20 on left side and 20 on the right side. So 40 millimeters altogether. So 20 here plus 100 plus 100 plus 20. Altogether it's 240 millimeter length. Height is 100 millimeter, it's directly given. And width is diameter of this circle. Radius is given 50 millimeter. So cylinder has diameter 100 millimeters. And that becomes, because that is the widest portion of the object. So that is the width of the object. So with these dimensions, we'll construct 3 rectangular boxes. This is rectangle. Length 240, height 100. Then length 240, we have projected for top view. Now leave some space between front view rectangle, top view rectangle, approximately 20 millimeters, and complete rectangle for top view. Which 2 dimensions you get in the top view? Length horizontal and width vertical. Width is 100. Which 2 dimensions you get in the front view? Length horizontal and height vertical. Yes, this height is to be transferred in the side view. And width is vertical. Width is also 100 millimeter to be transferred in the side view. Which 2 dimensions you get in the side view? Height vertically and width horizontally. So to draw side view, as usual, draw projectors from front view to top view. And how to project width from top view to side view, you know it now. So draw 45 degrees line and draw the projectors to complete the rectangle. So this is how this rectangle is for front view, this rectangle is for top view, and this rectangle is for side view. Okay. Now let's proceed for parts. Let's focus on the base plate first. So when you want to construct the plate, its largest surface that you should draw first. Largest surface of the plate reveals its shape. Now shape of this plate appears in the top view. So naturally in remaining 2 views, this plate appears like a strip of thickness 20 millimeters. Let's focus on the top view. So curved edges first, then principal edges, and then non-principal edges. Do you remember the procedure I've given you? So let's proceed. To draw these curved edges on the 2 sides, we'll locate center of the curved edges. So width is 100 millimeters. In the top view, don't forget width is vertical. So I've located midpoint 50 millimeter and I've drawn center line. So this is a center line. So center line passing through the centers of these 2 holes. That line we have located. Now to locate center of this curved edge, which has radius 20, measure 20 millimeters and locate the center. Similarly on the other side also, measure 20 millimeters, from left end 20 millimeters, and from right end 20 millimeters. You will get center on corresponding center line. So this is how we have located centers of those curved edges. Now with these centers, draw these curved edges, but try to understand these curved edges are not semicircular or quarter circular. These edges on both the sides, on the right side and on the left side, these curved edges are longer than quarter circular edges but shorter than semicircular edges. But right now we don't know exact length of these curved edges. So draw thin curves first. So this is a curve of radius 20. It's not complete circle. Some portion of that circle is there as boundary edge. So just draw a faint curve here. Similarly on the other side also. Okay. Now since with the same centers there are circular holes, these 2 circular holes can be drawn immediately, and if you wish you can draw it afterwards also. I prefer drawing smaller details after completing major details. Now 120 millimeters, check here. I am drawing this curved edge. Watch here. Boundary of this base plate is tangent to the cylindrical surface, and that is why that cylindrical surface of radius 50 millimeters you should draw here in the top view. This center is at distance 100 plus 20, extreme left end, 20 millimeters up to the center line, and then 100 millimeters. Parallel to length dimensions 20 plus 100, 120. So I measured 120 millimeters and I have located center of this circle. So draw faint circle right now. Right now we don't have any intention to draw the cylinder. We are just drawing this plate. Because this plate, boundary edges of the plate meet cylindrical surface tangentially, that is why for reference we have drawn this circular edge. Now draw tangents to these curves. So this edge which is on the back side, non-principal edge I have drawn. Similarly, draw other tangents to the curve. And this is how you will realize how much portion of these faint curves are at boundary and make them dark. So watch here, this is that base plate. Right now our focus is on the base plate, not on this triangular plate, not on the cylinder. There is a hole in the cylinder, there is a slot. Don't think about that at all. This is base plate in the top view. Now this base plate has two holes. So draw those two holes. These holes also in the front view will appear dotted rectangle. Now simple. Now this is the base plate in front view. Project its length, and in front view you get height, and that height of the plate is 20 millimeters. So this is how the rectangular strip at the base. Similarly, draw end projectors from front view to side view and then from top view to side view. So when you draw end projectors from front view to side view and from top view to side view, you get rectangular strip here again. But right now initially we are projecting these holes also. So holes, dotted lines in the front view. Now I projected height of the plate in the side view, 20 millimeters. Check these two red horizontal projectors and draw end projectors from top view to side view. And this is how you have completed the rectangular block, that is side view of the plate. Now this plate has holes. Let's draw those holes also. So project holes in the side view. You can measure independently also. It's not necessary to draw projector from each and every detail. So this is how we have completed front view, top view and side view of this base plate. Okay, now next part is cylinder. But before we start for cylinder, don't forget that where cylinder or circular hole appears a rectangle, don't forget to draw the center line. So here it is a center line, here also it's a center line, and in the side view also there is a center line. Okay, now let's proceed for cylinder. Two concentric circles because it's hollow cylinder. Just check corresponding radius and draw these two concentric circles. Cylinders appear rectangle in other views. In a view circle, remaining two views rectangle. Simple. It's vertical cylinder, therefore in the top view it's circle, remaining two views rectangle. So draw end projectors and complete the cylinder. Height of the cylinder is, from base it is given 100 millimeters. So of course up to the top. Now, most important thing here. How to create the joint. Of course, we have studied it earlier in normal orthographic views. Now we are studying sectional orthographic views. But right now we are not drawing sectional front view. We are drawing as usual complete front view. So here this base plate, edges of the base plate meet tangentially to the curved surface. So we are going to create this joint. I've taken projector from front view to side view and top view to side view. So cylinder is ready in the side view also. Now check here how to create this joint, the tangential joint. I have drawn these projectors, these two red color projectors. Check here. This portion I have erased because it is tangential joint here. And these two edges, watch here, this non-principal edge and here this non-principal edge meets curved surface tangentially. So we'll use that proper notation to indicate the tangential joint. So this is how we have created this joint. Now in the side view also, where it is tangential to the curved surface of the cylinder, from that point you should draw projector. Check now, focus on this portion. The way we erased this edge, this dark line here, similarly here also I have erased that dark line. Check and show the curved joint in this manner. So from left side view, this joint is visible here. Okay. Now from the back side also we must show that joint, but remember here on the back side there is a slot, so some extra work is required. Till then we'll not draw that joint here. So let's proceed for the hole here. So this is how I projected the hole. And as you know now that when depth of a hole is not given, it is to be assumed a through hole. So we should draw dotted lines from top to bottom. So this hole is not just in the cylinder, it is extended up to the base of the object. Similarly, this hole in the side view. So we have completed the circular hole in the front view, top view and side view. Now there is a slot. Opening of the slot appears in the top view and it is from top to bottom. Let's draw that slot. 40 millimeters, check this distance. That edge of the slot, opening of the slot. This edge which is parallel to length is 40 millimeters from the center line. So here I have drawn a line which is 40 millimeters from center line. Measure 30 millimeters. This length is 30 millimeters. So 15 plus 15, I measured it symmetrically. And then up to boundary of the circle, draw edges parallel to width. These small short edges parallel to width. And this is how I have created the slot. Now this slot is running from top to bottom. Check here. Watch here. There is a vertical edge partially visible on the back side from corner. Similarly, from all these four corners of the slot, check here, this is rectangular slot, it has four corners, 1, 2, 3 and 4. From all these four corners there are vertical edges, and when depth is not given, it is assumed through slot. So you should get a rectangle here, a dotted rectangle from top to bottom. So any hole like this hole, in top view opening, in front view rectangle. Similarly slot also, in the top view opening, in front view rectangle, in side view rectangle. So we are drawing this slot right now in the front view. So simply draw projectors and draw the dotted lines. So these inner two dotted lines are for the rectangular slot, and these two dotted lines, outer two dotted lines, are dotted lines or hidden lines for the hole. So right now in the front view, hole is hidden, of course, and the slot is also hidden because it is on the back side. Now let's draw this slot in the side view. Check all the details now. Have you realized that boundary generator of the cylinder, check here, this generator, correct? It is no more here because this portion we have removed. So from left side, the generator which was initially appearing at boundary, because of the slot, that boundary generator is no more there. So this generator, this boundary now will have to erase. This boundary will have to erase. And from the sharp corner of the slot here at boundary, we'll have to draw projectors. So I have drawn n projectors of the slot from top view to side view. Remember, length we transferred in the front view and width in the top view, we get width vertically. So width of the slot we are transferring in the side view. That is the logic behind end projectors. So from top view to side view, we have transferred the width of the slot. Now, as I told you, the boundary generator is no more there, that is to be erased. So I have erased it. And this rectangular slot, watch here, this is a rectangular slot here. You never draw hidden line at boundary, remember. So this is a boundary edge of the slot, and hidden edges of the slot. So this is how we have completed the slot in all the three views. Now there are two triangular plates, one on the left side, one on the right side. Largest surface is triangle that appears in the front view. So measure 30 millimeter, this distance is given 80 millimeters, watch here, up to this edge, 80 millimeters up to this edge. So from boundary generator, it is 30 millimeters because the radius of the outer circle here, it is a 50. So 50 plus 30, that is 80. So that is why from boundary I measured 30 millimeter. Naturally from axis of the cylinder, it is 80 millimeters. Here you should draw this edge. So triangular shape can be created easily here in the front view. So I measured 30 millimeters, and this is how these two triangular plates in the front view. In other two views, these triangular plates will appear strips, and these two plates are attached symmetrically on the left side and on the right side. So these strips on the left side and on the right side we are going to draw symmetrically. So this is how we have projected. Now watch these edges which are parallel to width axis. Thickness 10 millimeters. We are drawing here 10 millimeter thickness. If not given with reference to other dimensions, you assume the thickness. So I have assumed that thickness 10 millimeters, and this is how I have drawn those two strips, and these two strips meet this curved surface of the cylinder, cylindrical surface. Similarly, draw end projectors from this triangular plates, that is height of the triangular plate you transfer in the side view, and along axis of symmetry draw those two strips. So this is how these triangular plates I have transferred in the front view, I have completed in the front view, top view and side view. You can count those two plates. You can count those two plates in the front view, in the top view. But in the side view, when you are watching object, imagine from left side, the two triangular plates coincide, overlap. So this is the triangular plate which is visible from left side, and there is a hidden triangular plate which overlaps with this. So corresponding dotted lines now will not appear here because dotted lines for the triangular plate overlap with the visible plate. Okay, so this is how we have completed entire drawing. We have completed this drawing, but actually in this topic we are going to study sectional view. We are asked to draw sectional front view. Also these arrows, these two arrows suggest you that section is visible from front, and portion nearer to observer, that is of course a front portion, is to be removed. So this is front portion and this is back portion. So front portion is to be removed, but not actually you should erase it. You should imagine it as a removed portion. This is front side and this is back side. Front portion is to be imagined removed. Remember, in sectional views, portion nearer to observer is to be imagined removed. Now, When you want to draw sectional front view, listen to all these details. Now we have started studying sectional views. When you want to draw sectional front view, you should draw corresponding cutting line, cutting plane line we say. That is this line AB. Either in the top view or in the side view. Now listen to the statement I am making. When you want to draw a sectional view, then cutting plane line should appear in any one of the other two views. That is, if you want to draw sectional front view, cutting plane line must be in the top view or in the side view. If you want to draw sectional top view, then cutting plane line must be either in the front view or in the side view. So when you want to draw a sectional view, cutting plane line must be in one of the other two views. Okay. Now here we want to draw sectional front view. So cutting plane line must be either in the top view or in the side view. But now listen to me very carefully. Either in the top view or in the side view, but it is not your choice. It is not your choice. You should show cutting plane line in that view in which less number of hidden details are. Listen once again. You must draw cutting a line in the view in which less number of hidden details. Now we want to draw sectional front view. So we must draw cutting line in the top view or in the side view. Now check top view and also side view. In the side view, there are many hidden lines involved. So less number of hidden details. That means in the top view, we should show cutting plane line. Have you realized? Have you understood? Be sure. When you want to draw sectional front view, cutting plane line must be either in the top view or in the side view. But remember, to show the cutting plane line, we prefer the view in which less number of hidden details are. So cutting plane line must be in the top view. And this cutting plane line AB, watch here, passing through the centers of these two holes, making two parts of the object. How to draw cutting plane line? So this is center line, not yet cutting plane line. We must make boundary or end dashes dark. So I made end dashes dark. Now this is cutting line. This cutting line you can show in the side view, but I have explained you, we must draw cutting plane line in which less number of hidden details. So we have preferred cutting plane line in the top view. These arrows, arrow A and arrow B, I have drawn here. Okay. Now cylinder gets cut. Cylinder gets cut. Base plate also gets cut. Remember, in sectional view, boundary between the two parts which are attached to each other or which are in contact. For example, here this is cylinder and base plate. Now this edge here I have erased, I have removed. In sectional views, the two portions which are in contact, for example here cylinder and the base plate, boundary between the two will not appear. Watch here in the side view, this is cylinder and under the cylinder this is base plate. So this line is boundary between the two portions. This line is boundary between the two portions. So such boundary was there initially, this line, these edges. Watch here, right now I have removed those edges. So remember, boundary between two portions to be erased. It will not appear in sectional view. Now, triangular plate and cylinder. Is this line boundary between cylinder and triangular plate? Yes. So whether we should erase this line? No. Now why not? Try to understand. But before that, watch this line also. Is it boundary between triangular plate and the base plate? Yes. Tell me whether we should erase this line? No. Now try to understand again. Cylinder and the base plate, there was a boundary here, but I have removed that, and I instructed you that when two portions get cut by a cutting plane, boundary between the two portions of the object does not appear in the sectional view. Then why we must not erase this boundary or this boundary? Try to understand. This is a thin triangular plate. Such plates connecting major parts of object or major portions of a machine part are called ribs. So this triangular plate is a rib. Ribs are plates, thin plates, which connect major portions of machine parts to increase strength of machine parts. Such plates, such thin plates or ribs, we never consider getting cut by a cutting plane. We assume these ribs intact. So now make a rule here. Never cut ribs, or in other way, you can remember in this manner. That is, when largest portion of a plate appears in sectional view, when largest portion of a plate appears in sectional view, then that plate is assumed uncut. So we have assumed that this plate is not cut, and therefore there will be no hatching lines here, and that is why these two lines will remain as they are. So what you studied here up till now in sectional views, try to understand. In sectional views, the portions of the object which get cut, boundary between those portions we must erase. Such boundaries will not appear in sectional views, remember. And then if largest surface of a plate appears in sectional view, excuse me, then the plates are assumed uncut. So this triangular plate, and also on this side triangular plate, we should assume uncut. That means we are not going to draw hatching lines in these triangular plates. So even if actually because of this cutting plane cylinder gets cut, base plate also gets cut, these two plates also get cut, but we should assume these two plates uncut. That is the rule in drawing. So remember, thin plates or ribs, when their largest portion appear in sectional views, then those thin plates must be assumed uncut. Okay. So first we thought about boundary of portions in sectional views. Now hidden details. Try to understand. Some hidden details get cut because of cutting line. Some hidden details get exposed because of the cutting. Some hidden details remain hidden even after cutting. Some hidden details get exposed because of cutting. Some hidden details remain hidden even after cutting. Now check here, this hole is getting cut by the cutting line. So this hole is now visible. Also this hole is getting cut. So this hole is visible. And this hole of cylinder, this vertical hole of diameter 52 or radius 26 is also getting cut by the cutting line. So this hole also gets exposed. So these three holes are no more hidden now. So check here. Focus on these three holes. I have removed those dotted lines and now made this hole visible. Similarly, here I have removed these two dotted lines and this hole is now visible here. Now focus on this hole. That also I have made visible. So remember, those hidden details become visible because of cutting. Of course, you should make them visible in sectional view. So those hidden lines now no more hidden. So this hole is visible, this hole is visible. Watch here, this entire rectangle here, this small rectangle here is the hole, inner surface of the hole. This is inner surface of the hole. And this rectangle, watch here, that is also inner surface of this bigger hole in the cylinder. Now one more important thing. As I told you, because of cutting, some hidden details get exposed and become visible. Some hidden details remain hidden even after cutting. So this slot is hidden. Even after cutting it is hidden. And such hidden details are not required in sectional views. So we should erase these two hidden lines. I am erasing those hidden lines. Remember, in sectional views, we don't draw hidden lines. Those hidden details which get exposed because of cutting, we make them visible. And those hidden details which remain hidden even after cutting, we should remove. They will not appear in sectional views. So now, this is the front view after the object is cut. That is sectional front view. Now, because of the cutting, new surfaces are getting created. We should draw hatching lines on the surfaces. Now try to understand. This small rectangular surface here, it is newly generated surface. It is portion of the base plate. This L-type surface, this L-shaped surface, that is newly generated surface. Now triangular plate here, as I told you, it is assumed uncut. So no hatching lines here. No hatching lines here. This rectangle here at the center, that is inner surface of the hole. It is original surface which is getting exposed after cutting. It is not newly generated surface because of cutting of solid portion of the object. Here solid portion of the cylinder and the solid portion of plate gets cut. That is why this is a newly generated surface. So identify newly generated surface, simply avoid holes and largest surfaces of plates and draw the hatching lines. So here I have drawn hatching lines, here hatching lines, here hatching lines, and so this is how we have completed sectional front view. So once again we'll revise those 4 important points I have told you. In sectional views, boundary between portions which are getting cut does not appear. Some hidden details get exposed because of cutting. We should make them visible in sectional view. Some hidden details remain hidden even after cutting. We need not show those hidden details. In short, you can say that no hidden lines, no hidden edges in sectional view. On your screen, watch this sectional view, know where there is hidden line. If largest surface of a plate appears in sectional view, then don't show hatching lines on the largest surface of the plate. Such plates are to be assumed uncut. Cutting plane line. When you want to draw a sectional view, cutting plane line appears in one of the other two views. So here we have drawn sectional front view. The corresponding cutting line is in the top view. We must not draw the cutting line in the side view. As I told you, we should draw cutting line in the view in which less number of hidden details are. Okay, now this is the final drawing. We have used first angle method of projection. Insert all given dimensions properly. When it is complete circle, we should insert diameter. When it is portion of circle, we should insert radius. All given dimensions in the given pictorial view, we should insert in our final drawing. This is symbol for first angle method of projection. Thank you for watching the video. We'll meet soon. In my next video, we'll solve some more problems on sectional orthographic views. Till then, bye-bye.